Last thing we're going to do is a proof. We're given parallelogram ABCD, and they're asking us to prove that quadrilateral ABFE, this smaller one right here, is also a parallelogram. So the first thing I'm going to do, because I have some information about the little parallelogram and some information about the big parallelogram, or the little quadrilateral, I should say for now, is I'm just going to redraw the whole so that I can keep separate what I know about the whole parallelogram from the little quadrilateral, and just so we don't get a whole bunch of confusing markings. Okay, so we got that done. All right, the most important thing with any proof is that you have a strategy. And the first thing is just what's given, right? But two, the next thing is what else do you know? So the first thing you want to do, obviously, is look at the given. But as soon as you do that, you want to say, what else do I know because of that? So for instance, they're giving you that ABCD is a parallelogram. So right away, without doing anything else, you know that AB is congruent to DC. You know that AD is congruent to BC. I mean, AB is, yep. And then you also know that AB is parallel to DC. And you also know that AD is parallel to BC. Okay, so you know all those things just because it's a parallelogram. One other thing, though, that you're going to know because of that, and it's going to help us here, is that if you look at the little quadrilateral, AE is a part of AD, and BF is a part of BC. And if those parts are on bigger segments that are parallel, then those parts must also be parallel. So I know something right there about AE and BF. I know that they're parallel. Okay, let's move on to the other information that they're giving us in the given. So they say E is the midpoint of AD. So E is the midpoint of AD. So I know that AE and ED are congruent. And F is the midpoint of BC. So I know that BF and FC are congruent. Okay? So the third thing, though, the big thing is, at this point, after you've written down everything that you know without any leaps, right? Which method are you going to use, right? Which technique, which method, which option, right? And what I mean by that is, right now we have 5 different ways that we can prove a quadrilateral is a parallelogram. If you remember them, great. If you don't, you should have that chart up next to you while you're doing this. And you should be thinking, which one of those methods am I going to use? And so I'll tell you the way that I think about it. Right now, I need to prove that this little quadrilateral is a parallelogram. Well, I already know something about their lengths. I know, some relationship about their length. I also know that AE is parallel to BF, right? So I know a lot about that. And so what I'm going to try to do is I'm going to try to prove that AE and BF are congruent and parallel. Because if I can show that one pair of opposite sides are congruent and parallel, then I know that the shape is a parallelogram. So that's what I'm going to do. So the first thing I'm going to do is just write down what I know based on the information we have given. And I'll try to do this in a paragraph style. Okay, so we know that AE is parallel to BF. Right? And the reason is because they're parts of parallel segments. And if the larger segments are parallel, then any piece of it, any segment of it is also going to be parallel. Okay, so I already know that. Now, what do I know about their length? Well, this is a little bit more challenging, but we can still figure that out, right? So I know that 2, right? I know that AE is half of AD. I'm going to write it like this, right? Because I know it's the midpoint. I know that AE is the same as ED, right? But another way to put it is I know that AE is half of AD. And I also know that BF is half of BC, and I'll write it like this, okay? And our reason is, again, that's just a definition of a midpoint. Okay? So now, I'm going to go and look back at our larger parallelogram for a second. I know that AD is the same as BC, right? I know that these are congruent because it's a parallelogram. So AD and BC are the same. wherever I see one, I can replace the other one, right? Or I can substitute one for the other. So what I'm going to write right here is, again, and I know right here, I'm just going to highlight it right here, right? I know that AD is the same as BC. So I could replace one for the other. Either one is fine. But so I'm going to rewrite this now as this. I'm going to write that AE equals BC over 2, right? All I did was I substituted BC in for that AD because I know that they're the same. I know that they're congruent, right? So all I did right there is I substituted. So my reason is substitution. Okay? But if AE is equal to half of BC and BF is equal to half of BC, then I know that BF and AE are the same thing, right? If two things are equal to the same thing, then they must also be equal. And that is just a transitive property. So I know that AE is congruent to BF. And that's the transitive property. Okay? But so now look what we've already done. We've already proven that AE and BF are parallel and congruent. And if you can show that one pair of opposite sides are parallel and congruent, you are done. So there's nothing left for us to do, right? We checked all the boxes. So all we have to do is just finish our statement, right? We know that quadrilateral ABFE is and I'll use my little symbol, parallelogram. And the reason is because, and I can straight, because AE and BF are congruent and parallel. And that is it.